Have you ever lost marks on a test just because you rounded wrongly, or stared at your calculator wondering why your answer doesn't match the answer key? Let me show you 3 questions that confuse almost every Sec 1 student the first time they see them. By the end of this video, you'll know exactly how to answer all 3. If you're a Singapore Secondary 1 student learning approximation and estimation in eMath, this video is for you. In the next 17 minutes, you'll master rounding, significant figures, calculator techniques, and estimation. No more confusion, no more lost marks. Let's get started. Here's our roadmap. We'll start with a quick rounding recap, then understand what accuracy really means, dive deep into the 5 rules for significant figures, learn how to handle calculator answers, practice estimation, and wrap up with a quick recap. You can use these timestamps to jump to any section you need. Let's start with a super quick recap. The number 12,753 has 5 digits. The 3 is in the ones place, 5 in the tens, 7 in the hundreds, 2 in the thousands, and 1 in the 10,000s. You learned this in primary school, but we need it fresh in your mind for what comes next. Let's round 12,753 to the nearest thousand. Step 1. Find the thousands place, that's the 2. Step 2, look at the next digit to the right, that's 7. Step 3, ask yourself, is 7 5 or more? Yes, it is. So we round up. The 2 becomes a 3, and everything after it becomes 0. 12,553 rounds to 13,000. Now decimals. To round 36.721 to 2 decimal places, we keep up to the hundredths. That's 36.72, and check the next digit, which is 1. Since 1 is less than 5, we round down, so it stays 36.72. But if we round to the nearest whole number, we keep 36 and check the 7. 7 is 5 or more, so we round up to 37. Here's the rule that works every time. Find the place you're rounding to. Look at the next digit. If it's 5 or more, round up. If it's less than 5, round down. And here's the key. You only look at that one digit. Don't try to round in multiple steps. That causes mistakes. Now let's talk about accuracy. Most students think accuracy just means how many decimal places you have. But that's not quite right. Accuracy is actually about how much meaningful information a number contains. Let me show you what I mean with 2 real examples. Example 1. 2 agencies report visitor numbers. Agency A says 12,153 visits. Agency B says 13,000 visits. Both numbers have 5 digits. So which is more accurate? It's 12,753. Why? Because those last 3 digits, 7, 5, 3, give us real specific information. The 13,000 has zeros because it was rounded. Those zeros don't tell us the actual count. So even though both have 5 digits, 12,553 is more accurate. Example 2. A table is measured as 1.2 meters or 124.5 centimeters. Both measurements show 1 decimal place. So which is more accurate? It's 124.5 centimeters. Even though both have 1 decimal place, 124.5 actually contains 4 significant digits, 1, 2, 4, 5. But 1.2 meters only has 2 significant digits. More meaningful digits means more accuracy. And that brings us to the most important concept today, significant figures. So what are significant figures? They're the digits in a number that carry meaningful information about its accuracy. Now here's a tricky question. How many significant figures does 13,000 have? 2, 3, 4, 5? The surprising answer is, it could be any of these, depending on how the number was rounded. That's why we need clear rules. There are 5 rules, and once you know them, you'll never be confused again. Rule 1 is the easiest. All non-zero digits are significant. Look at 4,273. Every digit, 4, 2, 7, 3, is not 0. So we count all of them. That's 4 significant figures. Same with 3.45. 3 digits, none of them 0. 3 significant figures. This rule is your starting point. Rule 2. Zeros between non-zero digits are significant. Take 2022. That zero sits between the first two and the second two. It's trapped in the middle, so it's not just a placeholder. It tells us something real about the number. We count it. 4 significant figures. Same with 7.0291. The zero is between 7 and 2, so it counts. 5 significant figures total. Remember, if a zero is trapped between other numbers, it's significant. Rule 3 is for decimals. In a decimal, zeros before the first non-zero digit are not significant. They're just placeholders. Look at 0.0013. Those 3 zeros at the front just tell you where the decimal point is. We ignore them. We only count the 1 and the 3. 2 significant figures. Same with 0.487. The first zero doesn't count. Only 4, 8, and 7. 3 significant figures. Think of leading zeros as arrows pointing to where the real number starts. Rule 4, still in decimals, but now we look after the non-zero digits. In a decimal, zeros after a non-zero digit are significant. Why? Because they show the measurement was done to that level of precision. Look at 0.68. We ignore the leading zero, but that last zero after the 1 tells us the number is known to 4 decimal places. So we count 6, 8, 1, and 0. 4 significant figures. For 3.030, we count all 4 digits. That middle zero counts because of Rule 2, and the last zero counts because of Rule 4. Rule 5 is the tricky one. In a whole number, trailing zeros may or may not be significant. It depends on how the number was rounded. Let me show you with one example done 3 ways. We'll start with 1699.9 and round it 3 different ways. Watch what happens. Scenario 1, round to the nearest whole number. We look at the ones place, so 1699.9 becomes 1700, and we treat all 4 digits as significant. Scenario 2, round to the nearest 10. Same result, 1700, but now we only counted from the tens place, so only 3 significant figures. Scenario 3, round to the nearest 100. Still 1700, but now only 2 significant figures count. Same final number, but different accuracy depending on the rounding context. That's why 13,000 from our earlier question can have 2, 3, 4, or even 5 significant figures. It depends what the question tells you. Okay, time to test yourself. Pause the video now. Question 1. How many significant figures in 0.0035? Question 2. How many significant figures in 3.145050? Think through the 5 rules we just learned. When you're ready, unpause and I'll show you the answers. Answer for question 1. 0.0035 has 2 significant figures. The leading zeros are just placeholders from Rule 3. We only count the 3 and the 5. Answer for question 2. 3.145050 has 6 significant figures. We count all of them. The first 4 digits are non-zero, so they count. The 0 between the 5s counts because of Rule 2, and the trailing 0 counts because of Rule 4. If you got both right, you're doing great. Let's recap the 5 rules fast. 1. Non-zero digits always count. 2. Zeros between non-zeros count. 3. Leading zeros in decimals don't count. 4. Trailing zeros in decimals do count. 5. Trailing zeros in whole numbers depend on context. Here's a pro tip that makes everything easier. Just find the first non-zero digit and start counting from there, applying the rules as you go. Now let's talk about calculators. You type in a calculation and your calculator shows 1.6006414,894 and keeps going. But the answer key says 1.61. What happened? Don't worry. You're not wrong. You just need to learn 2 steps, truncation and rounding. Let me show you exactly what to do. Here's a real example. Calculate 4.11 divided by the square root of 13.1 minus 1.03 squared. Give your answer correct to 3 significant figures. Step 1. Punch it into your calculator. you get 1.6006414,894, and so on. Step 2. For your written working, truncate, that means cut off, after about 4 or 5 significant figures. Write 1.6064. Don't round yet, just cut. Step 3. Now round your final answer to 3 significant figures as asked. Look at the 4th digit. It's a 6, which is 5 or more. So round up. The answer is 1.61. That's 3 significant figures. Done. Here's the number 1 mistake students make: double rounding. Never round your working value, then round again. That changes your answer. The right way is to keep a truncated working value, like 1.6064, and then round once at the very end to the significant figures asked for. 1 calculation, 1 rounding, right at the end. Follow that rule, and you'll never get it wrong. Now let's talk about estimation, or as some people call it, aggregation. What's the difference between approximation and estimation? Approximation is rounding one number, like saying pi is approximately 3.14. Estimation is rounding every number in a calculation to nice, simple values, so you can do easy mental math and get a quick, rough answer. This is super useful when you don't have a calculator or want to check if your calculator answer makes sense. Let's work through an example. We want to estimate 4.97 minus the cube root of 8.02, all divided by 1.957. The question says round each number to 2 significant figures. Step 1. 4.97 becomes 5.0. 8.02 becomes 8.0. 1.957 becomes 2.0. Step 2. Rewrite the expression with these simple numbers. Step 3. Calculate in your head. The cube root of 8 is 2. 5 minus 2 is 3. 3 divided by 2 is 1.5. Done. Our estimated answer is 1.5. No calculator needed, and it took about 10 seconds. Your turn. Pause the video now. Round each number to 1 significant figure, then calculate the answer mentally. I'll give you the expression. 2.92 squared minus square root of 4.09 divided by 0.5001 times 9.94. Round each of those 4 numbers to 1 significant figure and work out the answer. Pause now and unpause when you're ready to check. Here's the answer. Step 1. Round to 1 significant figure. 2.92 becomes 3. 4.09 becomes 4. 0.501 becomes 0.5. 9.94 becomes 10. Step 2. Rewrite and calculate. 3 squared is 9. Square root of 4 is 2. 9 minus 2 is 7. In the denominator, 0.5 times 10 is 5. So 7 divided by 5 is 1.4. The estimated answer is 1.4. If you got it right, well done. Estimation is a powerful skill once you practice it. Let's recap everything in 5 quick points. 1. Rounding. Find the place, check the next digit, round up or down. 2. Accuracy means more meaningful digits, not just more decimal places. 3. Significant figures. Know the 5 rules and always start counting from the first non-zero digit. 4. Calculator work. Truncate for your working steps and round your final answer once to the required significant figures. 5. Estimation. Round all the numbers to 1 or 2 significant figures and do easy mental math. If you understand these 5 things, you're ready to tackle any approximation or estimation question. Oh, what's next? Practice. Open your workbook and try 10 questions. For each one, check how many significant figures are in the given numbers and write your final answer correct to 3 significant figures. I've made a free practice worksheet. The link is in the description below. If this video helped you, please hit the like button, subscribe for more Sec 1 math help, and leave a comment telling me which part was most useful, rounding significant figures or estimation. Thanks for watching, and I'll see you in the next video.